Good day everyone, I am Giselle D. Gulusinda and today we are going to tackle about the chapter 6, Weather Observation and Forecasting. This chapter has 3 topics: the meteorological instruments and their uses, weather maps and symbols, and the basics of forecasting. First, let us talk about the meteorological instruments and their uses. So in order to gather data about the atmosphere, meteorologists rely on a variety of instruments. And with the use of these instruments or tools, they gather important information about various weather elements that enable them to monitor and predict weather patterns. I have here 10 examples of meteorological instruments and their uses. First is thermometer. A thermometer is a tool that is used to measure and collect temperature data of a current area. Second is a barometer. A barometer is used to measure the atmospheric pressure, which allow the meteorologist to predict short-term weather changes by identifying the rising or falling pressure trends. The third instrument is the hygrometer. Hygrometer is a meteorological tool that measures the changes of humidity in the air. The fourth instrument is anemometer. It is primarily used to measure the wind speed, which is very important for weather forecasting because it allows meteorologists to predict weather patterns, identify potential storm, and also to assess the severity of wind gusts. The fifth instrument is the rain gauge. A rain gauge is used to measure the amount of liquid precipitation that falls over a specific area in a given period. The sixth instrument is the sunshine recorder. Sunshine recorders are used to help predict climate change by monitoring sunlight hours, and it also provides data for monitoring weather patterns and in assessing solar energy. The seventh instrument is the weather satellite. Weather satellites are used to monitor and track cloud formations, storm systems, atmospheric temperature, moisture content, wind patterns, and other weather phenomena across large geographical areas. The eighth instrument is the ceilometer. A ceilometer is a weather instrument for measuring the height of the cloud ceiling or the cloud base. The ninth instrument is a radar. A weather radar is a powerful tool that is used to detect and track precipitation, including rain, snow, hail, and even tornadoes. And also, the radar data provides valuable information about the intensity, the location, and the movement of a storm. Lastly is the wind vane. A wind vane is used to measure the direction of the wind. It indicates which direction the wind is blowing from. And also, the data from the wind vanes can be used to calculate the average wind direction and the fluctuations during specific periods.
Welcome to our weather report. Today, we're diving into the fascinating world of weather maps and symbols. These tools help meteorologists predict the weather, and knowing how to read them can make you a weather whiz. There are several types of weather maps, each giving us different information. The first one is the surface weather maps. These maps shows temperature, pressure system, and wind patterns, helping us understand the current weather. The second weather maps is the satellite maps. Satellite images provide a broad view of cloud cover, storm systems, and large-scale weather phenomena. The third one is the radar maps. Radar maps use technology to detect precipitation intensity, storm movement, and potential severe weather events. The last one is the weather forecast maps. These maps use atmospheric data and models to predict upcoming weather conditions. Weather symbols are like a secret code. helping us decipher the weather conditions. Let's break down some of the most common symbols. First one is the cloud symbols. Different symbols represent different cloud types, like cirrus, cumulus, and stratus give us clues about the weather. Next is precipitation symbols. Symbols for rain, snow, hail, and sleet tell us what type of precipitation to expect. Third one is wind symbols. Wind direction arrows and strength indicators help us understand wind patterns. Fourth is temperature symbols. Thermometers and color-coded map represent temperature variations. Fifth is pressure system. High and low pressure symbols are crucial for understanding weather patterns. Last, storm symbols. Distinct symbols represent cyclones, tornadoes, and hurricanes alerting us to severe weather potential. Weather broadcasters interpret these maps and symbols to provide accurate forecasts for your area. They use their knowledge to tell us what to expect. So next time you see a weather map, don't just glance at it. Take a closer look. Understanding these symbols and maps can empower you to be more prepared for anything the weather throws your way.
Hello, everyone. As we wrap up our journey through Chapter 6, we will be discussing the Lesson 6.3, which is the basics of weather forecasting. This is where we put everything together to understand how meteorologists predict the weather. So let's get started. First, let's define the weather forecast. Well, a weather forecast is essentially a scientific prediction of future weather conditions. Weather conditions refer to the state of the atmosphere at a specific time, described by the most important weather variables. So, to answer our questions about what the weather will be like tomorrow, meteorologists use advanced technology to measure the conditions of the atmosphere to make these predictions, such as the humidity, pressure, wind speed, and direction. In forecasting the weather, meteorologists need to know the existing weather condition over a large area before creating a more accurate forecast. Moreover, the forecast decision is based on the use of various forecasting tools. So earlier we heard about many tools that have specific scope and functions designed for weather observation. And these observations are used to forecast weather. So, so to clarify, weather observation is like gathering ingredients for a recipe, while weather forecasting is like using those ingredients to cook a meal. Observations provide the raw data, and forecasting uses that data to predict what the final outcome will be. So there are four types of forecasts. We have nowcasting that ranges 0 to 6 hours. It focuses on immediate weather conditions and short-term changes, often using high-frequency data from surface observations and radar. We also have the short-term forecast that range 1 to 3 days. It combines data from surface, upper air, and remote sensing tools to predict weather for the next few days. So let's move on to the medium-term forecast that range 3 to 7 days. It uses a combination of observations and numerical weather prediction models to forecast weather for the upcoming week. And for the long-term forecast that range 7 days to several months, this relies more on climate models and long-term trends, often using data from remote sensing tools and historical observations. So basically, long-term forecasts are less accurate than nowcasting.
The basic steps in weather forecasting. So we have here the five basic steps. First is the observation, then collect and transmission weather data. Third is plotting weather data. Fourth is the analysis of weather maps, satellite, and radar images, and other data. And for the last step is the formulation of the forecast. The first step is the observation. By the way, there are three types of weather observations. The surface observation measures weather conditions at ground level. The upper air observation that measures weather conditions in the upper sphere. And the remote sensing uses instruments to collect weather data from a distance.
The observation of different weather elements are made simultaneously as follows. For surface observations, it made at least every 3 hours over land and sea. Land-based weather stations around the world and automatic stations observe the atmospheric pressure, wind direction and speed, temperature of the air, humidity, clouds, and precipitation, and the visibility using standard weather instruments such as the barometer, wind vane, anemometer, thermometer, psychrometer, or hygrometer, and rain gauge. In addition to these, coastal weather stations, weather ships, and ocean data buoys observe the state of the sea by observing the height and period of wave. The upper air stations around the world also make observations at least every 12 hours. The pressure, temperature, dew point temperature, wind direction, and speed are observed at selected levels in the atmosphere using radio zones which record this data by tracking helium-filled balloons attached to transmitters. Another apparatus, the theodolite, is used in observing wind direction and speed, also at selected levels. In addition to this, commercial airplanes observe the weather along the routes at specified times. Meteorological satellites, geostationary and polar observing, which are belong to the remote sensing, take pictures of the cloud imagery of the atmosphere. These satellites take picture of the Earth's cloud formations every hour and continuously respectively. Weather radars are also used to observe the cloud coverage within the range of the radar. A vast array of weather data are fed to the computer, which analyzes them as programmed and makes a time integration of physical equations. This is called numerical weather predictions. So, in numerical weather prediction, atmospheric data from various sources such as surface observations, weather balloons, satellites, and radar are input to supercomputers. These computers have up-to-date material models that can use much more data and make more calculations that would ever be possible by scientists working with just maps and calculators. Meteorologists can use these results to give much more accurate weather forecasts and climate predictions. So the second step in basic weather forecasting is the collection and transmission of weather data. The transmission of weather observations condensed into code of figures, symbols, and numerals is made possible using radiophone, telepipe, decimal machine, or telephone. The collected were further transmitted to the central forecasting station, where their satellite pictures were transmitted to ground receiving stations, while radar observations were transmitted to the local communication system. The third step is plotting weather data. The coded message was decoded, and each set of observations is plotted in symbols or numbers on weather charts over the respected areas or regions. 4 times a day, the observations made over land and sea are plotted on the surface or mean sea level charts were prepared. Moreover, theodolite, radiosonde, satellite, and aircraft wind observations are plotted on upper level charts, prepared twice daily. So the first step is the analysis of weather maps, satellite, and radar imageries and other data. The current weather maps are analyzed as follows. So the surface chart or the MSL. The data plotted on this map were analyzed isobarically. This shows that interconnection of atmospheric pressure in different places were presented with a line, taking consideration of the wind direction. This analysis identified the high and low pressure areas, tropical cyclones, warm and cold fronts, and intertropical convergence zones. The upper air chart, the data plotted on this weather map were analyzed using trimline analysis. Lines illustrate the flow of the wind. With this type of analysis, anticyclone high pressure areas and cyclones or low pressure areas can be delineated. Numerical weather model output. The computer plotted weather maps are analyzed manually so that weather symbols like anticyclones, cyclones, troughs, etc. are located. For the monitor weather chart, in the cross section, the plotted data, rainfall, and 24 hours pressure change were analyzed to determine the weather waves movement, the behavior of the atmospheric pressure, and rainfall distributions. Here are the following steps for analyzing current weather maps. So we have here, compare the current weather maps with the previous 24 to 72-hour weather maps level by level to determine the development and movement of weather systems that may affect the forecast area. Next is to examine the latest weather satellite picture, noting the cloud formations in relation to the weather systems on the current weather maps. Third is to compare the latest weather satellite picture with the previous satellite pictures up to 48 hours, noting the development and movement of weather systems that may affect the country. Next is to examine the latest computer output of the numerical weather prediction model, noting the 24-hour, 48-hour, and 72-hour objective forecast of the weather systems that may affect the forecast area. Last is to analyze the latest radar reports and other minor forecasting tools. So for the fifth step and the last step, basic weather forecasting, we have the formulation of the forecast. After the analysis of all available meteorological information or data has been completed, the preparation of forecast follows. The first and one of the preliminary steps is the determination as accurately as the data permit of the location 24 hours hence of the different weather systems and existing weather over a particular region. In many cases, a fairly satisfactory estimate of the direction and rate of movement may be made by simply measuring the movement during the last 12 or 24 hours and then extrapolating or extending this movement into the future and hence what weather will be experienced in different areas in the immediate future. Now, how weather forecast disseminated? Well, the forecast is shared via radio stations and telefax a few minutes after completion. It is immediately sent to weather stations nationwide. Copies are provided to media outlets without the delay. Next, let's look at the two major weather services. So the National Weather Service, or the NWS, is an agency of the United States federal government that provides weather forecasts, warnings of hazardous weather, and other weather-related products to the organization and the public. This agency's primary goal is to ensure protection, safety, and general information. The NWS is part of the National Oceanic and Atmospheric Administration, or the NOAA, under the Department of Commerce. It is headquartered in Silver Spring, Maryland, within the Washington metropolitan area. The NWS performs its task through a collection of national and regional centers and 122 local weather forecast offices. Now, let's move on to the PAG-ASA, or the Philippine Atmospheric, Geophysical, and Astronomical Services Administration. So, PAG-ASA is the National Meteorological and Hydrological Services or Agency of the Philippines. PAG-ASA is mandated to provide protection against natural calamities and ensure the safety, well-being, and economic security of the public. It is also promotes national progress by undertaking scientific and technological services in meteorology, hydrology, climatology, astronomy, and other geophysical sciences. Pag-asa created on December 8, 1972 by reorganizing the Weather Bureau. Pag-asa now serves as one of the Scientific and Technological Services Institutes of the Department of Science and Technology or the DOST. So finally, let's discuss the benefits of weather forecasting. I have four listed in here: the safety and life protection, the economic impact, personal planning, and emergency preparedness. So of course, the safety and life protection. Weather forecasts provide crucial information to help people prepared for upcoming weather conditions, potentially saving lives by offering early warnings or severe weather like storms, heat waves, and floods, allowing for necessary precautions to be taken. They also benefit industries like agriculture by enabling farmers to optimize planting and harvest schedules based on predicted temperature and precipitation patterns, ultimately impacting economic prosperity and quality of life. The second is the economic impact. So, in agriculture, farmers can use weather forecasts to make informed decisions about planting, irrigation, and harvest timing, optimizing crop yields. And for transportation, companies can plan logistics and adjust routes based on anticipated weather conditions, that minimizing disruptions. For the personal planning, individuals can plan outdoor activities based on predicted weather, avoiding potentially dangerous conditions. And for the emergency preparedness, communities can prepare for potential weather related disasters by understanding upcoming conditions and taking preventive measures. So, to wrap things up, weather forecasting is a vital tool that helps us prepare for and respond to various weather conditions. By understanding the processes and benefits of weather forecasting, we can appreciate the importance of accurate weather predictions in our daily lives. Stay safe, stay informed, and make the most of the weather. Thank you.